Good morning. Well, maybe it's not morning for you, but it is morning for me. We are going to be talking about inductive and today deductive reasoning. So yesterday we talked about inductive reasoning in class. Remember, inductive reasoning was when we were noticing something happening. So we were noticing a pattern, something that was repeating a lot. And so we would make a conjecture based on that. So inductive was just kind of observing something happening. Today we're going to talk about deductive reasoning, which is a different type. And then we're also going to assess the validity of a logical argument, basically saying, is it true or false? If it's false, using what we learned yesterday to give a counterexample. Now I wrote on here, there is a lot of writing today. So if you want to go ahead and pause the video now and go and print these notes, all of the notes today are obviously writing down the actual notes, and then all of the answers today are like sentences, they are words. So if you'll go ahead and print the notes ahead of time, all of the definitions will be there for you, and you can just simply fill in the answers with your pencil or pen. So first thing we're going to talk about is the law of detachment. So this is one of the, we're going to do a few different theorems and like concepts today. One of them is law of detachment. This is when you have a conditional statement. So remember, the conditional statements are if this, then that. So the law of detachment is a conditional statement when the hypothesis is true and then the conclusion must also be true. So it's kind of sounds weird. Let's just look at an example. So it says the conditional statement is, if you pass the final, then you pass the class. And so from that, it says you went ahead and you passed that final. So what conclusion can you make? So based on the law of detachment, it says the hypothesis is true, the conclusion must also be true. So the hypothesis being that you passed the final. So notice that you passed the final. And then the conclusion was you passed the class. So they said one thing that happened here is that you did actually pass the final. And so what conclusion can be made based on this conditional statement up here? If you pass the final, what always happens? And so it says, what conclusion can you make? You can make the conclusion that you have passed the class. So if you pass the final, then you pass the class. You passed the final, and so what happened? You passed the class, okay? So that is law of detachment. Let's try another one. So the conditional statement, it says, if it's Friday, then Mary's going to go to the movies. Today is Friday. What conclusion can you make then? If today is Friday and Mary goes to the movies on Fridays, and today is Friday, what's the conclusion? Well, the conclusion is she's going to the movies, right? So if this happens, then this happens. And then it says the if part, it happened. And so the conclusion, of course, is that she's going to the movies. All right, now this one's a trick. I'm just going to tell you up front. Okay, the conditional statement says, if it is morning, then I will drink coffee. I am drinking coffee. What conclusion can you make? Now, everyone wants to say, then it must be morning. But can you drink coffee in the afternoon? Well, sure. Can you drink it at night? Sure. So just because they are drinking coffee doesn't mean it must be morning. No, it does not. So the conditional statement's hypothesis is if it is morning. Is this the hypothesis as well? No, that is the conclusion. And so because this part is the conclusion, then you cannot make an additional conclusion based on that. If the hypothesis says it is morning, then this right here must say it is morning in order for you to make a conclusion. But because it actually matches up with the already given conclusion, you cannot make an additional conclusion from there. So this one has no conclusion. This is the one that tricks people every year. I'll say, it is morning. If it's morning, I drink coffee, and I'm drinking coffee. What conclusion can you make? And everyone goes, it's morning. No, it could be evening, even if I'm drinking coffee. So make sure its conclusion comes second. Hypothesis, then conclusion. All right, next one we're going to talk about is the law of syllogism. The law of syllogism reminds me of this commercial. I don't know if you guys remember this, but several years ago, there was this insurance commercial where the guy was like, if you don't buy Progressive insurance, then you're going to regret it later. Because if you regret it later, it's because you ran your car into a tree. And if you run your car into a tree, then you're going to need to go to the hospital. And if you need to go to the hospital, then you're going to run into a doctor, and if you run into that doctor, then he's going to have to treat you with whatever. It was like this long commercial, and at the very end, it was like, what could you do to avoid all of this? You could have just bought Progressive insurance. But it's like, the whole point of me telling you this story is it says, if this happens, then this is going to happen. And then if this happens, then this is going to happen. And if this happens, then this is also going to happen. It's just this really long, continuous thing. So this reminds me of this law here, the law of syllogism. It says, if A happens, then B is going to happen. And if B happens, then C is going to happen. And so essentially what they're telling you is, if A happens, then C would end up happening. So they're kind of jumping from the beginning of the commercial to the end of the commercial, right? And so the law of syllogism basically just is showing that these all connect, and therefore, and therefore you could just say from here to here and just cut off all the stuff in the middle. Okay, now it does have to go in order, right? A leads to B, B leads to C, and therefore A eventually will lead to C. And so this is the law of syllogism. So let's practice with this down here. So it says, use the law of syllogism to write a statement that follows with the pair of true statements. So it says, if Bob takes biology, so I'm going to call this right here, that's A. If he takes biology, then Tim will be his partner. So this would be B. It says, if Tim is his partner, so this right here, does that match up with the thing we just read? Tim will be his partner, Tim is his partner. Okay, yes. So these are both B, right? They say the exact same thing. So they're both B. And then the last part says, then Bob will get an A. So that would be C. So basically what we're going to do is we're going to cut out the middleman. The stuff here that is B is going to get cut out, and we're going to just say, if A, then C. If A, then C. And so what would that actually say? It would say, if Bob takes biology, then what? Then Bob will get an A. So if Bob takes biology, then Bob will get an A, because all of that stuff in between is going to take us from A all the way eventually to C. So let's just cut out the middle stuff and say A leads to C. Okay, so that's the law of syllogism. All right, let's try another one. I'd love for you to try this one on your own. It says, if it is raining outside, so that would be my A, I will wear my rain boots. So this right here would be B. Now, is the next part also B? It has to go in order, remember? So check, is that next part the same as what B says? If I wear my rain boots, so is that the same thing as the previous B? I would say yes. Then the last part says, I will be excited. So that would be C. So we're going to write if A, then C. So if it is raining outside, then I will be excited. Okay. Again, that's the law of syllogism. All right, next, we're going to finally hit what we were talking about from the beginning. We were going to talk about deductive reasoning. So remember, inductive is what we talked about yesterday. Today is deductive reasoning. It says it uses facts, definitions, or properties, etc., so like law of syllogism, etc., to form a logical argument. Now, my question to you is, how is that different from inductive? So if you flip back in your notes, I have it right here. It says inductive reasoning is when you find a pattern in specific cases and then write a conjecture for the general case. So inductive is when you observe a pattern, right? And you're just kind of walking around living your life and you keep seeing something happening over and over again. So you're observing that thing. Deductive is using facts. So it's not like you noticed something happening. It's that it is definitely black and white. It is a fact, like x plus 2 or 2 plus 2 equals 4. That is a fact, right? It's not something you observed. So inductive is when you can see it happening or you're noticing it happening, and deductive is when you have like a dictionary and it has the definition right there, okay? So let's practice seeing if we can find the difference between the two. So in this example, it says, decide whether the following are inductive or deductive reasoning and explain why. So here's our first one. It says that Monica notices that when she kicks the ball up, it returns back down to the ground. So the next time she kicks the ball in the air, she's saying it's going to come back down. So did she notice something? Did she observe something happening? Did she see a pattern? Or is this based on fact? Now, a lot of people say, well, it's based on fact because gravity's going to pull it back down. Notice that it doesn't say anything about gravity here. It just says she notices. So that is our key word here. She notices. And so since she's making an observation, we're going to call that inductive reasoning. Okay, and notice that I highlighted the word notice because that's what gave me the clue that it was inductive. All right, next. Part B says, all reptiles are cold-blooded. Now, first of all, did you notice that, or is that true? It's a fact. So all reptiles are cold-blooded. Parrots are not. They are not cold-blooded, and so Sue's parrot is not a reptile. Now, is that based on fact, or did she notice that this happened or see it happening? Is it a pattern? So all reptiles are cold-blooded, fact. Parrots are not cold-blooded, also fact. Sue's parrot must not be a reptile then. So that observation here, or this last portion here, Sue's parrot is not a reptile, what is that based on? Is that based on a fact, or is it based on a pattern? And since it is based on a fact, we would call that deductive. Okay. Let's do one more. It says all multiples of 8 are divisible by 4. All multiples of 8. So before we even get too far, multiples of 8 would be 8, 16, 24, 32, 40, 48, 64. Whoops. Go back. Here we go. Let's stop there actually. 48. And so, think about that for a second. Is that a fact? All multiples of 8, so 8, 16, 24, etc., are divisible by 4. Is that something that is an observation, or is it always true? It is a fact. So kind of think about that. And so they are saying 64 is a multiple of 8. Therefore, 64 must be divisible by 4. Is that a fact, or is that something that's a pattern that we're noticing? So although it is a pattern, right, this is a fact that it is happening, and so this is deductive. Okay. All right, that's actually it for today. So let's double check. Did we cover what we said we would cover? Did we talk about deductive reasoning? Absolutely. Remember, deductive is based on fact or definitions. And then we also talked about the validity of logical arguments when we were talking about the law of syllogism, the law of detachment, etc. So this assignment here is just a continuation of what you did yesterday. So remember, you were already on page 74 yesterday, and someone even said, why are there not very many problems? So we're finishing page 74. Now, these are going to be collected on Canvas as 2 separate grades. So make sure that when you upload this, you choose the right day. This is for the 16th. So make sure that you're on that before you upload it. All right, guys, have a great rest of your day, and I'll see you soon.